All right, let's get started here. Welcome everybody. I'm Sean Gilligan. My talk is Cypherpunk Java with Nix. Welcome to Nix Vegas 2025, the first Nix Vegas. My name is Sean Gilligan. You can find me on GitHub as MS Gilligan, and my email is here too. Feel free to reach out if you have any questions or comments. I will make this kind of interactive, so if you have a question, just let me know. Oops. So I'm going to talk a little bit about cypherpunk principles. I think I'll be preaching to the choir. The disclaimer is I don't consider myself a cypherpunk yet. I'm more of an aspiring cypherpunk, but I'm trying. I'm going to talk a little bit about how I got to Nix and how it's kind of becoming more of a cypherpunk has led me to Nix. I know that a lot of people in the Nix community and also in the Bitcoin community that I deal with a lot tend to be pretty hostile to Java. So I'm going to talk about, what has Java done for us lately? And the answer is a lot. I'm going to talk about some of the projects that I'm working on that I'm hoping that are both responsible for my transformation and that I'm hoping to kind of deliver on these cypherpunk principles. The first, there are two related projects. The first one is a cryptography library for elliptic curve cryptography called with the wonderful name SecP256K1 JDK. There's also a library called Bitcoin J that I'm the junior co-maintainer of, and then I'm going to talk about how Nix solves some of the problems we're having in developing these libraries, and then I'm going to present an example that uses Nix derivations to do some builds. So how many people are familiar with Eric Hughes and the Cypherpunks manifesto? Okay. It's a famous document from 1993. It has the famous phrase, "Cypherpunks write code. We publish our code so that our fellow cypherpunks may practice and play with it. Our code is free for all to use, worldwide." I wonder what he would think of Nix. I think he would like it. He's still around, I haven't asked him. I keep pushing the wrong button. What are cypherpunk values? Privacy. They want to make privacy tools available, and they want them to come from a trusted source. That's where Nix comes in. People want to have autonomy over their software and hardware, and there's not much more autonomous than a Nix config. I left out the quote where he talks about having did I leave out the quote where he talks about software that you can play with? Did I edit that down? No. Cypherpunks may practice and play with it. That is also a very Nix-like principle. I really loved the art and the whole concept of the great tree that they were using with Nix Vegas. So I wore my existing Yggdrasil t-shirt, and now I have a new one that I got from the conference. It makes me really happy. One of the cool things about Nix, as most of you know, is it has one of the largest library of open source software of all the package managers. And that's what they were calling, first time I've heard it was in reading about this conference, the Great Tree. Another excerpt from the Cypherpunk manifesto that's near and dear to my heart is where he talks about we need anonymous systems with electronic money. So I'm a Unix person at heart. I did my undergrad at UC Berkeley and UC Santa Cruz, and Unix and C are kind of in my DNA, but I also became a Macintosh developer in the early days of Macintosh. And it was really hard for me to not have Unix underneath this beautiful GUI that they had. And now, of course, I'm on Mac OS X, and I use Mac OS 10, and I use Nix because it runs on both Mac and Darwin. So all my demos are going to be on Darwin and Linux. I actually played with Darwin when it was an open source operating system that you could install before Apple backed away from that. So when I started working on Bitcoin J, the lead developer, Andreas Schildbach, had made some decisions that really frustrated me. The first of which was there were no binaries allowed in the repository. And for those of you that are Java developers, I think there's at least one or two here. You may be familiar with like the Gradle wrapper, which is a binary used to bootstrap your build. Not allowed in Bitcoin J. The second thing is that he insisted that everything be able to build according to Debian free software guidelines, which meant using this ancient version of Gradle known as Frankengradle. That's included with Debian. It's actually a build of Gradle 4.4 when the latest version is Gradle 9. The reason is that Gradle now needs Kotlin, and Kotlin is really hard to bootstrap. And Gradle is really hard to bootstrap. So they stick with this ancient version and they patch it to make it work with the newer JDKs. Now, of course, Nix is going to solve this, right? But so these are some of the things that led me more to the Cypherpunk world, working with Andreas, contributing to Bitcoin J, and dealing with some of these issues around Java that aren't very friendly to to the free software world. All right, I'm going to take a little detour and talk about modern Java. A lot's changed between 2014 and now. As of Friday, Java 25 went to release candidate. For the last 10 years or so, they've been doing a new release every 6 months, and they've really done a nice job. I'm not a fan of Oracle, the corporation, but I will say that they've kept their good engineers. They've given them a lot of autonomy to do the right thing, and they've really cleaned up a lot of long-standing issues with Java, things that I thought I'd never see fixed. They put out a new long-term support release every 2 years, so Java 25 will be the long-term support release. It's coming out in September. It's not numbered by year. There will be a 26 in early 26 and a 27 in September 26. So there's an algebraic formula where you subtract and multiply by 2. So I'm just going to run through all the features that have been added in the last 10 years. I'm showing which version of Java is listed. I'm showing the LTS version that added that feature, not when it was previewed or when it was first released in a general availability. So with 8, we got lambdas, streams, default methods and interface, optional type, completable future, which is like a promise. It's also for the functional programmers. It's actually a monad. New time API, 11 added modules, a new HTTP API, reactive streams. You can use var if you want to. There's actually a REPL and shebang execution are now supported. JLink lets you build a custom JRE just for your project, and it's used nicely in Nix packages these days. They added switch expressions, which are a lot like the match expression in Rust. They also have pattern matching that works with them. Records are immutable objects without a lot of the verbosity of Java beans, and the mutability and verbosity of Java beans forever banished. Sealed classes allow you to do things like Rust enums if you're a Rust developer. They created a packaging tool which can be used to bundle a JDK You have multi-line text blocks. Hex format is like a little thing, but damn it, why did it take them so long to add that? Virtual threads is like Go routines, pattern matching and switch, snippets in your code, sequence collections. Panama is a really important thing. It's known as the Foreign Function and Memory API. It became final in Java 22. It's a new way of calling native code from your Java, and I'm going to talk about that because my demo uses it very effectively, I think. It went final in Java 22, and it's becoming long-term available in 25. The nice thing is you don't have to, if anybody's used JNI, you know that it's very, very painful, it's tedious, and it's error-prone. The Panama API, which I won't have time to get into, really makes it a lot simpler and a lot nicer. And it also works pretty well with Nix if you bring in a dynamic library as a Nix dependency, you can link to it and use it directly versus the older JNI way. You typically bundle things inside of a jar. They also finally simplified Hello World with something called implicit classes and instance main methods. They've added structured concurrency. There's a vector API, that's still early access. And Valhalla adds value types where you're able to not create things on the heap. And then GraalVM is the native compilation tool. It includes a native compilation tool. It also has polyglot language support and a Java VM actually written in Java. It's a pretty advanced piece of compiler technology, and I can't say that I really understand it, but I do really like the native image. And so the example that I'm going to give is something compiled with GraalVM to generate a native image, and then it's using a native C library that's linked with the Panama FFM API. They've also removed a lot of stuff. Applets are gone. They removed the security manager because it wasn't, they removed the security manager. They also removed the SecP256K1 elliptic cryptography, elliptic curve cryptography curve. But I have added it back using a library from Bitcoin called libsec256k1. Okay, so I'm going to go through this fairly quickly, but the example that I'm using and a project I've been working on is to create a new reference implementation of the SecP256k1 curve for the JDK and JVM languages. It's based on this C API, which is wrapped with the Foreign Function Manager. It uses the standards for efficient cryptography group SecP256k1 curve. The Java library is modeled after the C library because they did a really nice job of making it hard to shoot yourself in the foot. And so with Java, we're just able to simplify it and make it, a little less verbose. We're using functional return types. We're using, we've got garbage collection, so you don't have to worry about pointers and things like that. The interesting thing that we've done with SecP256k1 is we have two implementations. One that uses this best of breed C library, and another that uses a library known as Bouncy Castle. Not going to demo the Bouncy Castle today because I'm really focused on the native thing because that's been my main focus and it's most interesting from a Nix perspective. So the libsecp library was created by the Bitcoin core group after they moved away from OpenSSL. I'm going to go through this pretty quickly because I think we're limited on time. So these are the library jars. You can see they're probably a little bit bigger now, but there's an API jar that you use, and then there's the foreign function, the FFM implementation, and there's a Bouncy Castle implementation. when you compile against it, you just compile against the API jar, and then at runtime you can deploy it either way. The native one, of course, requires 22 or later, and with 25 being the LTS, we're actually gonna just set the requirement to be 25. This is the example program that I'm going to show. It basically generates a key. It's based on the C example from the C library. It basically generates a secret key, generates a public key, signs and verifies. This is the signing code. This is the verification. This is not using the simplified hello world yet, because one of the things is that JDK25 is not available in Nix yet. I actually created a fork and put in the Graal VM 25 early access, and I'm using that for this demo. But one of the things I'm hoping to personally contribute to the Nix ecosystem is to help get new releases of Java supported faster, so that they can, so that packages can migrate, so that we can start debugging them earlier. Bitcoin J is a library that is about 15 years old, and when I started working on it, I realized that it really needed some major updates. So we've been kind of modernizing it along the principles of modern functional style Java, while maintaining a lot of backward compatibility, because one of the major use cases has been Android wallets. Andreas really feels that it should support a wide variety of inexpensive Android phones, and he holds us back so that it can be used all over the world from people that maybe can't afford newer phones, and it's available. It's available in the. I'm drawing a blank on the name of the App Store, the Android App Store.
Play Store?
No, not the Play Store.
F-Droid?
It's F-Droid. It's available in F-Droid. Yeah. There's a few apps powered in it. The Bitcoin Wallet by Andreas Schildbach is one of the major drivers. There's a Bisq peer-to-peer networking app. There's also this is the history of the project. I'm going to skip over that. Release 18 is going to have the new SecP library. All right. So how does Nix help? How many people here are familiar with the way Maven repositories and Java packaging is done? 2. Okay. It's, huh? Horror. No, actually not. I actually with the I actually think that the Maven and Gradle may have their problems, but having pre-built binaries that you can pool based on a coordinate of group, artifact, and version works pretty well, and it's actually very similar to Nix, with one major thing that's missing: being able to rebuild it from source. But a lot of times you get into these dependency hell situations with where you try to get everything onto the same dependency. The Maven repository system, like Nix, allows each app to declare its dependencies and have its own tool chain that can essentially be version locked. So when you bring that into Maven, you get some mismatch issues because they work differently, and there's some hacks to resolve that, and I'll show that briefly just before I do the demo. One of the other things that's interesting to me about Nix is that source is the metadata called source provenance. Is everybody familiar with that? Yeah. In the package, I'll go over it briefly. In the package metadata, there's a metadata field called source provenance, and there's a handful of values that you can use for it. So you can say it's source code, it's built from the source. You can say that it's a precompiled binary. There's also a category called bytecode, which is what you'll use if you pull in a precompiled Java jar library. One of the reasons I think for Nix's success is that it does allow you to bring in these things that were built as binaries. That's why the package repository is so large. But if you really want bootstrappability, which for me is the holy grail and something that I'm pursuing, then you want to see more things having source provenance. So for example, for this demo, I'm using a GraalVM build that's not built from source. OpenJDK is built from source. There's also like Zulu and Tamarin, which are other builds of the JDK that are brought in as binaries. One of kind of my long-term goals is to see more bootstrappability in the components that I'm working on. Yep. All right. So I originally got this working with a bit of a hack. If you don't want to do a full Nix package, you can use a dev shell and just say, and just call and just run the dev shell to do your build. I do that in GitHub Actions, for example. But seeing Fareed's demo yesterday, I said, God damn it, I'm going to convert this to actually being a full Nix package, which I basically did with a few caveats. This thing keeps rotating. Was there a clamp? Yeah. No, I might have done that. Yeah. Thank you. Can everybody see this?
Yeah.
All right. So this is a little bit of a hack because this is my first time doing this actually for real. But I have two packages of the same utility. Again, it's that Schnorr signature example. I have one build that uses that generates the Java bytecode and runs it with the JIT, and I have another that compiles it completely native to C. I didn't use Flake utils, so right now it only works on R64 Darwin, but I have tested some of this on Linux and on x86. So because the build is done with Gradle, I mentioned there's this thing called there's this extra step called fetch deps that pulls the jars down and basically version locks them. I think it's called a fixed output derivation, I believe. Yeah. So you have to run like a pre-step to build this deps.json file, and then it runs the Gradle task to do the build, and then in the install phase it just copies the jars, and then it makes a wrapper. Note that this is using the Java module system, which is the newer way of deploying. Of running Java. It provides more tightly, tighter boundaries and access control between modules, which I think is quite good for security. For example, you can see in here that it specifically enables which modules are allowed to call native code. One of the things that's been added to Java recently is this whole initiative around secure by default or integrity by default. So you now have to, if anything's going to access native code, you have to explicitly permit it when you compile your app. So in theory, this could provide some protection against a supply chain attack where you bring in another module that tries to do something fishy. If it's not enabled to talk to your native libraries, it won't be able to. This one here is the build of the native package, which also uses Gradle, but it uses a different Gradle task, which does the native compile. And then in the install phase, I learned a few things about this. It actually creates it actually uses wrap program to create a link to the library. You can use patch elf, or there's something on the Mac, I forget what it's called, an equivalent thing on the Mac, but you can't use that with the GraalVM code that calls a native image because it uses DLOpen. So the actual library name isn't there in the executable. So you have to use this technique of, oh, here it is. You can see I have it commented out. Install name tool won't work. You have to use wrap program. There are ways of telling native image to build a more static executable, and I'm going to look into that in the future. But for this current build, at least, this wrap program was the way to go. Okay, so I thought I'd show that these examples actually run. First, we will run. Can everybody see this, or should I make it bigger? A little bigger? So you can see when I run the Schnorr example, which is the one that actually uses the JVM, it runs in about 186 milliseconds. And the output's the same, but if I run the native version, we're down to 35 milliseconds. And then the other thing I was going to show is what the wrappers look like. So this is the wrapper for the JVM version. You can see that on the Mac, OpenJDK actually maps to Zulu, and you can see that it's directly pulling it from the Nix store. You can see the enable native access for just the FFM module that I mentioned. You can see the library paths, and that's how the native version is run. That's how the JIT version is run. For the native version, you can see that it's setting up this dynamic load library path to the native C library in the Nix store, and then running based upon that. So what you're seeing when this runs is you're seeing natively compiled Java calling the Panama FFM capability, which then calls a natively compiled library, and built with all the native stuff being pulled in via Nix, which is really nice. So this is maybe the future of Cypherpunk Java. Any questions? All right.
Like
Oh.
if an org took this on, right? Like an organization took this on, would you no longer need to ever publish to repository? You just do everything using Nixcap?
That's a really good question. Now, let me restate the question. The question is, if some organization took this on, would there be a way to replace the public Maven repository with the Nix cache?
Yeah. Or even like your local, a lot of times I'm a local Maven.
Or your local Maven? That's a great question, and I think about that a lot.
I've done it, yeah.
You can do it yourself for a small project using Nix. I've played around with that. I think Fareed has done that. But to try to move the entire ecosystem would be really difficult.
Not the entire open source ecosystem, but like, yeah, a small.
But maybe some subset. You know, I'm wondering if there could be some, more. Like for example, one of the things I've done with the SecP JDK library is and Bitcoin J, both of them I've really worked hard to minimize dependencies. So SecP, has the dependency on the C library, and it has only one other dependency, which is something called JIT-specify, which actually gives you really good null annotations, almost as good as Kotlin, and it's interoperable with Kotlin, so it's really nice. But with only those two dependencies, I do have the option of just pulling them in directly from Nix. The thing is, you also, if you publish a Java library, you also want to support the non-Nix Java community. So, one of my goals with the SecP library is to use Nix for the reference build. Bitcoin J, because I'm the junior maintainer, I defer to Andreas, who likes to do that using Debian and Podman. But I would like to be able to do a reference build of the SecP library using Nix. It should be reproducible with other build tools if you set all your options right. But would it be possible to create something that sort of looks like a Maven repository more dynamically, and not use this man-in-the-middle deps.json technique? That's something I'd like to learn more about, and once maybe in a year or so, it's something I might look at a little. And if anybody has any ideas about that, please, I'd love to chat. Any other questions? Okay, thank you, everybody.